All right, for 2.2, we're going to take solving inequalities a step further, and we're going to solve them using addition and subtraction. So no vocab today. We're going to start off with examples. Example 1, solve each inequality. So we have part A is x minus 6 is greater than or equal to negative 10. We're going to solve this the same way we would if it were an equation, by using inverse operations and GEMDAs backwards. So it's x minus 6. We're going to get x by itself by adding 6 to both sides. Cancels out on the left, and I have x is greater than or equal to negative 10 plus 6, which is negative 4. And we're going to graph this on a number line. I like to put numbers around it so that I know where it is. If you just want to put negative 4, that's fine. But remember to graph, we put a circle where the number is. If it's or equal to, which it is, I shade it in. If it's not equal to, don't shade the number in. And so now I have x is greater than or equal to negative 4, so my arrow points to the greater numbers. And there we go. All right, part B is 1/4 is greater than y minus 1/4. We're going to get y by itself, so we're going to add 1/4 to both sides. And 1/4 plus 1/4 is 2/4. We're going to simplify to 1/2 is greater than y. And again, inequalities are much easier to graph if the variable comes first. So 1/2 is greater than y is the same thing as saying y is less than 1/2. It's just reading it backwards. So now we're going to do a number line. And I'm going to have 0, 1, and 1/2 is in the middle. So circle on 1/2, it is not equal to, so that circle stays open, and then y is less than. So our arrow goes to the lesser numbers. All right, and part C and D here are a continuation of example 1. If you would like to pause the video at this time and solve them yourself, you can, and then check to see if you got it right. All right, I'm going to go ahead and solve C. So negative 8 is less than 1.4 plus m. I need to get m by itself, so I'm going to subtract 1.4 from both sides, and negative 8 minus 1.4 is negative 9.4 is less than m. And it helps if the variable is first, so I'm going to switch that to m is greater than negative 9.4. All right, and then we want to graph it, so here's my number line. Here's negative 10. Here's negative 9, and somewhere in here-ish would be negative 9.4. Circle on negative 9.4. M is greater than, so I point to the greater numbers. And it's not equal to, so I don't shade in the circle. All right, negative 4 is less than 6x plus 7 minus 5x. I noticed something on the right side. I have some like terms I can combine or simplify. So 6x minus 5x is just 1x. So I'm going to rewrite this as negative 4 is less than x plus 7. Because 6x minus 5x is 1x. All right, now I get x by itself by subtracting 7 from both sides. Negative 4 minus 7 is negative 11. It is less than x. And it helps to have the variable first, so x is greater than negative 11. I'm going to write this on a number line. And circle on negative 11. X is greater than, so it goes to the greater numbers. And it's not equal to, so it's not shaded in. All right, example 2 is some problem solving. A circuit overloads at 1800 watts of electricity. You plug a microwave that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading it. All right, so if it overloads at 1800, that means whatever power we're using has to be less than 1800. This is not equal to because it overloads at 1800. I don't want to risk overloading the circuit, so less than 1800. You plug a microwave in that uses 1100. So you're already using 1100 plus x. So whatever you add to that still has to be less than 1,800. So that's part A, which we're actually supposed to solve too. So if we subtract 1,100 from both sides, I'm left with x has to be less than 1,800 minus 1,100, which is 700. X has to be less than 700. All right, so in addition to the microwave, which of the following appliances can you plug into the circuit at the same time without overloading the circuit? Well, whatever it is, it has to be less than 700 watts. So, can I plug in the clock radio? Yes, I can. 50 is less than 700. Can I plug in the blender? Yes, I can. 300 is less than 700. Can I plug in the hot plate? No, I cannot. 1,200 is greater than 700, which would overload the circuit. All right, and yes, I can plug in the toaster, which is 80. So if I had an appliance that was 700, I could not plug that in because then the total would be at 1,800 watts, which would overload the circuit. It has to be less than 700. So if it's at 699, it works. 700 or higher does not. All right, let's wrap it up with some summary questions. How do you solve a simple linear inequality using addition or subtraction? Well, we use inverse operations just like we would with an equation. Undo the addition or subtraction to get the variable by itself. How are solving equations similar to solving inequalities? We just kind of answered that. You still use GEMDAs, you still use inverse operations, you still want to get the variable by itself. And how are they different? Well, just like we said in 2.1, inequalities will have a range of answers, a set of answers, instead of just one solution. All right, so in class, I'm going to have you guys do this exit ticket at the bottom. If you would like to try it on your own in the video now, you can. We'll go over it in class though.